All right, let's talk about one of the weirdest, most important, and honestly, most overlooked forces in the entire universe. We're going to explore the force that's all about one thing: change.
I mean, think about a force that's so incredibly faint, so gentle, that right this very second, trillions of its little messengers are zipping straight through your body, and you don't feel a thing, not a single one.
And yet, this same ghost-like force is so absolutely crucial that without it, our sun would just go out. Every star in the sky would go dark, and yet life as we know it wouldn't even be a possibility.
So what's its secret? Well, it's because this force has a superpower that none of the others do. It can actually reach into the very heart of an atom and change what it is. This is the wild story of the weak nuclear force.
So what exactly is this quiet, world-changing power? Let's figure out what makes it so different from the other forces you've probably heard about.
You know, the universe runs on four fundamental forces. You've got gravity, electromagnetism, the strong force, but the weak force, it's kind of the odd one out. Its job isn't to hold stuff together or push it apart. Its whole purpose is to rewrite the recipe of matter itself.
And this really gets right to the heart of it. The other three forces are like the universe's construction workers. They're the glue and the muscle, holding planets in orbit and atoms together. But the weak force, it's more like the universe's alchemist. It's the one that allows a particle to literally become something new.
Okay, so how does it actually pull off this magic trick? Well, let's look at its most famous move, a process that can change one element into a completely different one.
It's called beta decay. So picture a nucleus that's a little bit unstable, a little wobbly. The weak force can just step in, tap a neutron on the shoulder, and poof, it flips it into a proton. When that happens, an electron and a tiny little particle called an antineutrino get kicked out. But here's the kicker. The atom now has an extra proton. That means it's not the same element anymore. It has just transformed.
But we can go even deeper. So what's really going on here? Well, that whole neutron to proton switch happens because the even tinier particles inside them, quarks, are changing. A down quark in a neutron literally changes its flavor and becomes an up quark. And just like that, you've got a proton. This ability to change a quark's flavor, that is a power that only the weak force has.
Now, every force has a messenger particle that carries it, but the weak force's messengers are, well, they're surprisingly huge, and that explains why we call this force weak in the first place.
So meet the crew, the W+, W-, and Z0 bosons. These are the particles that actually are the weak force in action. Whenever a quark changes flavor, it's because it just interacted with one of these guys. They're the agents of all this transformation.
And get this, these bosons are absolutely massive. They're about 85 times heavier than a proton. That is just insane. It's like the delivery guy being heavier than the skyscraper he's delivering a package to. And that enormous weight has a huge consequence.
Because they're so heavy, they just can't travel very far. It limits the weak force's range to a space that's smaller than a single proton, and that's why we call it weak. It's not because it's feeble. Up close, it packs a punch. It's because its arms are just incredibly short. From any real distance, you can barely feel it at all.
Okay, so let's zoom out from the subatomic and see how this short-range force has an unbelievable impact on the biggest things out there: stars.
Right, so we all learned that gravity is what crushes hydrogen together and kicks off nuclear fusion in the sun. But what's the actual spark? What's the secret ingredient that lets that very first crucial reaction even happen? You guessed it, it's the weak force. The very first non-negotiable step in the sun's entire energy-producing chain is that two protons have to merge. But to do that, one of them has to turn into a neutron. And there's only one force in the universe that can do that job. Without the weak force, fusion just stops, before it even starts.
I mean, just let that sink in for a second. This quiet little subatomic process is the only reason our sun shines and gives us the warmth and light we need to live. Without the weak force, the universe would just be a dark, cold, and totally lifeless place.
And the weak force didn't just turn the stars on, it actually set the stage for them to even exist, way back in the first few moments of the universe.
Yeah, in that hot, dense soup right after the Big Bang, it was the weak force that was busy setting the perfect ratio of protons to neutrons. If it had been a little stronger or a little weaker, the whole recipe for the cosmos would have been ruined. You'd either get a universe with nothing but hydrogen or a universe with no hydrogen at all. Either way, no stars, no galaxies, and definitely no us.
And you can actually see the evidence of this force working all the time. In fact, it's passing through you right now. Trillions of these little ghost particles called neutrinos, all created by weak force interactions in the sun and stars, are flying through your body every single second.
These neutrinos are like the calling card of the weak force. They barely interact with anything, so they just stream across the universe. They are the tangible, flying proof that this quiet transformation is happening constantly, deep inside the heart of every star.
So you see, while it doesn't get the glory of holding galaxies together, the weak force is really the unsung hero of change. It's what powers the stars, it creates new elements, and it cooked up the ingredients for the universe right at the very beginning. It really is the quiet engine that drives all of cosmic chemistry.
And in the end, that's what it all comes down to. In a universe full of forces that pull and push, there's one that's dedicated to something totally different: transformation. The weak force, simply put, is the force that makes all change possible.